G'day, Year 8. This is the first of our week 2 lessons. The topic of today is range and interquartile range. Both of these are measures of dispersion. They're ways of measuring how spread out your data is. The example I tend to use is if you're walking down the street in the middle of Gallery Walk, you're probably going to find a massive variance in people's ages. There's going to be a large measure of dispersion. Things like your range and your interquartile range, they end up being big values because there's a lot of different ages there. But if I surveyed our class and ignored me, it's going to be a very small measure because the age of people in our class, it doesn't vary by very much at all. These are ways of measuring how spread out your data is, as opposed to the measures of central tendency we were doing the other day, which give a measure of what's a typical or a normal value. So this is measuring how spread out your data is. Another one that's used and you see later on in mathematics is something called standard deviation. That's often used in a lot of statistics, but it's got a really nasty formula and we don't do it in Year 8, don't worry. Right, so to start with, range and interquartile range. Range is definitely the easier one to calculate of this. Range you calculate by simply doing the maximum, the biggest value, subtract minimum, which is the smallest value, and it will give you an answer. We're going to do examples of this. I'm just saying this is a theory on a high level. This is what we're doing, and then we're going to drill down from there. Interquartile range is a bit trickier. You might not have seen some of this before. Interquartile range is what we call IQR for short. That means interquartile range. It's the third quartile subtract the first quartile. I'll write that in words. Third quartile subtract the first quartile. Now right now what I'd be doing is looking at you guys and going, do you know what a quartile is? The phone's not talking to me. So I'm going to assume you probably don't. Now, we'll go through this again in examples, but if you have your set of data, you know that the middle value when you put it in order is the median. If I was then to get the middle of the first half of the data, I'd be getting something that's, well, at about a quarter, isn't it? If something was about a quarter there, we might call it the quartile. We call that the first quartile. In theory, where a quartile sits, a quarter of your values will be less than it. So 1/4 of your values should be lower than the first quartile. Now remember the median, that half your values are above and half your values are below? Well, a quarter should be in here as well. And if I drew a line here at the third quarter, I might call that quartile 3. And hopefully you can see the relationship there. 1/4 of the data will be below the first quartile. 1/4 of the data will be between the first quartile and the median. 1/4 of the data will be between the median and the third quartile. And 1/4 of the data will be between the third quartile and the maximum. So the way you actually calculate it though is, well, you know how to calculate the median, I presume. Remember finding the median, the middle value? We did that in another lesson. To find the first quartile, we essentially go median of the first half of the data. That's how we find it. We split off the first half of the data and find the middle value. Third quartile, same deal, except it's of the second half. So we find the median of the second half of the data. Now all of that's probably sounding a bit weird. It's best shown by examples. Let's get into our examples. So I'm going to pick 8 numbers to work off. So example 1, I'm going to do 8 values. I'm going to, in this case, already sort them. Remember how we needed to sort the data to make sure we get the correct median? Same deal with the quartiles. Quartiles really are strongly related to median, as I've been pointing out here. Very similar in that you need your data set ordered before you're picking out which ones are which. All right, 5, 8, 12, 17, 18, 20, 21, and I'll go 28. There we go. All right, so to find the range, that's simple enough. So I'd write my formula. I like you get in the habit of that. Range is your maximum, subtract your minimum. The maximum is 28, the minimum is 5. Right, maximum is 28, biggest value. Minimum is 5, smallest value. Biggest value, subtract the smallest value. So the range is 23. It just signifies, well, yep, your values in your data set vary by up to 23. There's 23 between the lowest and the highest. Clearly, the more difficult here is the interquartile range. Now, if you were finding the median of this data, I'm going to start with the median. It's going to be smack in the middle here because there are 8 values. There's 4 values on this side, 4 values this side. All right, if I went in from the outside, you'd find, oh no, the median's stuck here between these 2 values. So if you're doing the median, I hope you're comfortable now with saying, well, the median has to be midway between 17 and 18. What's in the middle of 17 and 18? I'm hoping you recognise it's 17.5, but if I wanted to be technical, I'd add that 17 and 18 together and divide it by 2. The median is 17.5. Now to find the quartiles, we need to look at the first half of the data for the first quartile and the second half of the data for the third quartile. I'm going to show you that split in half. That's the first half of the data set. That's the second half of the data set. And I'll show this in the second example, if we had an odd number where the median was a particular value, we would disregard that median from each half of the data. I will show you that in the second example. But when we have an even number of data values like this, it splits very cleanly. This is half the data, this is half the data, simple, right? So to find the first quartile, we need to find the middle value of this first half of data. There's 4 values. It's going to fall right in the middle there, isn't it? Because there's 2 values above and 2 values below. What's in the middle of 8 and 12? I'm hoping you recognise it's 10. But if you weren't sure, add them together, divide them by 2. The first quartile is indeed 10. Same deal at the second half of the data to get the third quartile. All right, it's going to fall in the middle there because there's 2 values above, 2 values below. So between 20 and 21, I'm hoping that you realise that the middle of 20 and 21 is 20.5, but that's how I do it mathematically. Add them together, divide them by 2. So the first quartile is 10, the third quartile is 20.5. I wish I had more room on this board. I'd work downwards, but I'm going to have to show a little bit on the side here, unfortunately. The interquartile range we defined before as being the third quartile subtract the first quartile. So we put the values in. The third quartile is 20.5, the first quartile is 10. The interquartile range is therefore 20.5 subtract 10, which is 10.5. Your interquartile range is 10.5. In terms of interpretation, the most useful thing to think of here is, well, half of your data is within these values. Think about it. If a quarter of the data is here and a quarter of the data is here, that means half of your data is between the first quartile and the third quartile. So half of your values are within 10.5 of each other. That's how you would interpret the interquartile range if you wanted to talk about it. Do you want to talk about it? Do you want to talk about it? I have one of my children here who just completely snubbed me. Anyway, so here we go. I'm going to do a second example. So we're going to start with a nice clean board and we're going to do a really nice, interesting example with some real world data. Of all things, I've found data for the Australian women's cricket team T20 for February and March. I've got their scores. I just felt I should do something really random, and that's the most random thing I could think of because I'm not a creative person. That's why I teach you mathematics. All right, so here we go. Let's find range and interquartile range of a real life data set that's a little bit messier, not so much our friend. Okay, so here we go. The real data, I just have to grab from here. The data looks like this. 184, 134, 155. This is how many runs. In case you're not particularly familiar with cricket, they hit this thing with a bat and they get points that they run back and forward, or 4 if it just goes over the edge, or 6 if it's in the air when it goes over the edge of the field, and it's called runs. And yeah. And I think this is for T20, which I actually don't personally believe in, and I appreciate if it's also against your beliefs, that's okay. I'm actually not a big cricket person, don't worry. I just thought I should give something to the cricket people out there. If you have particular interests that you want to see turn up in data questions, always email me, I will do it. All right, I deliberately picked this to have 11 values, so hopefully I've written 11 values here, 5, 6, 7, 8, 9, 10, 11. These are from February, March. Now, as I've said before, when you're finding the median, what's the first thing you have to do at your data? Put it in order, right? First thing I'm going to do is put this data in order. So in order, oh, this is going to be a bit tragic, isn't it? You don't want to be doing this on the fly while you're videoing yourself. Okay, 104 is probably the lowest. Is it then 115? 115. Then 123. 132, 155 next, the two 155s, I hope. There's 156 down the bottom. That leaves, oh yeah, we've got 3 left. That looks reasonable. 173, 184, 189. One of the ways I checked that I've got this right is I'll go, well, that's 11 values. Is that 11 values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yay! Okay, we've got a chance of having it correct, which is always a good start. All right, so our 2 measurements. Firstly, range. Range was the maximum, subtract the minimum. The maximum value, now it's in order, makes it pretty easy. The maximum was 189. The minimum was 104. Put that in your calculator and you'll get 85. So the range of Australian women's cricket scores for this particular February-March was 85 between their lowest and their highest scores. So I probably should note that. It's Australian women's T20 cricket. All right, next up is, what was the second thing we were doing today? Anyone remember? Interquartile range. Right, so interquartile range is the third quartile, subtract the first quartile. So, as I've suggested before, easier to look for the median first. It's in the middle, and then you can split your data into 2 parts. So in this case, if you look carefully, the median is going to fall here. Why is it going to fall there? There's 5 values above, 5 values below. That is the median. But that's not what we wanted. We wanted third quartile and first quartile. Now, to do that, we need to section off our data into the first half and the second half. And this is important. When you have an odd number of data values like this and the median is a specific value, the way we show you to calculate it, and there's a lot of debate about whether this is appropriate or not at a very nerdy university level that I'll spare you of, but we regard the first half of the data as not including the actual median value. We regard the second half of the data as not actually including the median value either. All right, so that's our first half of the data, that's our second half. Whenever the median is a specific value, do not include it in the halves, okay? And we're all happy. In this case, the first quartile and third quartile are relatively easy to find. At this point here, if I'm looking for the median of the first half, right, the median of the first half, it's there because there's two values above, two values below. So that becomes the first quartile. Here, for the second half of the data set, the median of the second half falls right there. Median for the second half is 173 because there's two values above and two values below. So that there is the third quartile. Now we just need to put that in our formula now. We've found the third quartile, the median of the second half. We've found the first quartile, the median of the first half. All we've got to do is put that in a formula. So third quartile is 173, first one's 123. Third quartile subtract first quartile gives us 50. So in theory, half of the scores of the Australian women's T20 cricket team in February and March is within 50 points of each other. Between the first and third quartile, there should be about half the data, about 50% of the data in there. And that's what it means. Now with that knowledge, remember the first half and the second half of the data, the treatment is subtly different. If you have an even number, it just splits nicely into two groups. If you have an odd number, disregard the middle value. That's how you get your first and second half of the data. Slightly different depending on when you have odd or even number of values. Besides that, you've got examples here. That's how you calculate range. That's how you calculate standard deviation. It's over to you. Have fun and take over the world with data.